All right, so I've had a request to do problem number 23 out of supplemental 3. The color magenta consists of a mixture of red, about 700 nanometers, and blue light, about 450 nanometers. If you see a magenta colored section of a soap bubble, about how thick is the section of the soap bubble? Assume that the wavelengths in the material are shortened by a factor of 1.3. By the way, this is giving you a big hint as to what the index of refraction is. All right, so let's work through the solution. I will zoom out so you can see the paper. Zoom in just a bit. All right, so all colors are present in white light. And only certain are present in re-radiated light. And not only that, you want to make sure that you actually have constructive interference coming out so that you can see them. So we know that seeing magenta implies that we've got red and we have blue. Now if we look at, say, our rainbow, Roy G. Biv, that would imply then that there's no green. There might be a little, technically it might be a bit muddy. There might be some orange and yellow, but that can be kind of in the red family. So in this case, the reasoning is that green is a color you are not seeing, because that would drastically change the magenta perception. All right, so no green. Therefore, the film thickness of the bubble must be equal to half the wavelength of green. And so we've used green light a few times. It's about 550 nanometers. And this produces a minimum for green. All right, so in soap, N is approximately 1.3, which we were given in the problem. Therefore, the lambda of green light in soap so lambda prime, which is the lambda in soap, is approximately lambda over 1.3, which is 550 nanometers, over 1.3, which is 423 nanometers. And then for destructive interference, it must be lambda over 2. Therefore, we just take 423 nanometers and we divide it by 2, which is 212 nanometers. All done.